Okay, Algebra Unit 2, Lesson 1. So here's the warm-up for the first lesson. It says, evaluate or solve. The following do not convert to a decimal or a mixed number. All right, let's see. I have a fraction times a whole number. I like to put the whole number over 1, so I'm kind of picturing this like this, and then I'm multiplying across the top and getting a -4, multiplying across the bottom and getting a 3. Okay. Any whole numbers are actually on the top, whether they have a 1 underneath or not. They have imaginary 1 underneath. So that's just how whole numbers work. So if it helps to write them in, this is a negative fraction times a negative whole number, which is a positive. Across the top, a -2 times a -2 is a +4. Across the bottom, a 4 times 1 is 4. And anything that's a whole number over the same whole number, that's going to turn into a +1. Let me get my key out so I can make sure I'm not messing anything up. Okay, this is a -5 times a 1/3. So -5 times 1/3, I'm going to do that first. Order of operations say multiply something before you add and subtract. So -5 times 1 is -5 over 3, and I need to add that to a -2. Now the -2 is still over 1, and now that we're adding fractions, we cannot add two fractions that have unlike denominators. So we need an LCD. The lowest common denominator in this case between a 1 and a 3 is a 3. So I need to rewrite this. I can keep that fraction, but I need to turn the other fraction into something with a 3 over it. A -2 as a whole number is the same as what over 3? So 1 times 3 gets you the 3. So -2 times 3 gets you a -6. All right, I kept the negative with the number. I could have made this a -5/3 minus 6/3. I just think it's easier to look at it this way, though. So a -5 plus a -6 is a -11. Is a bigger negative. And when we're adding fractions, we do not go across the bottom here. Remember, I have -5 of these, and then -6 more of those. So I now have a -11 of those, and that does not reduce. Okay, this one right here is 1/3 times -2 over 1 plus a -2. If you can see that. If they wanted you to multiply all this together, they would have had multiplication parentheses there, but they didn't want you to do that. This is this times this, which we do first, and we get -2 over 3. And then I need to add to that a -2 over 1, if you can follow that. I need my LCD of 3 again, so I'm going to use this. And I need a -2 in terms of 3, and back over here we did that same thing and found out that a -6 over 3 would reduce to a -2. So I want to add my two negatives together and get a -8. Okay. All right, now we have an equation. These were expressions. This is starting the equations. So there are different tools for equations, and you have to recognize that, okay? Expressions were just simplifying, reducing. Equations, we are solving for a variable if they have one. So this time, for number 5, we're solving for y. Order of operations say multiply first. What is -4 times 0? That's 0. So y equals 10. All right, over here, multiplying. A negative times a negative is a positive. And then adding to get a -12. A -24 plus a positive. I'm adding these two terms together. The book says that the 24 is a larger number, so the answer is going to be negative when I add them together. It's kind of a subtraction. Same thing. Okay. All right. Equation. I have 1/3 x plus 3 equals 2. So I have a fraction. You can either move the 3 over, go 1/3 x equals -1, or I know some people prefer to just go ahead and multiply this by your LCD, this by your LCD, and this. So on the test, one of the things that people did a lot was forget to multiply this term. They remember the first one, they remember the last one, but the one in the middle. So all the terms in an equation need to be multiplied. That's why some people move one of them first, so they have fewer terms to multiply by, but it's unimportant. And remember, this reduces away, so you have 1x left. And because these two terms don't have anything on the bottom, we're just multiplying. So 3 times 3 is 9. 3 times 2 is 6. So that looks infinitely better than this thing over here. So then we just move the 9, and we get a -3 for x. Okay, you can always put these back in and give them a check to make sure that it was correct. So you can put 1/3 times -3/1 plus 3 equals 2. So -3 times 1 is -3. 3 times 1 is 3. This all turns into a -1. So -1 plus 3 is 2. Okay? All right, over here, let's see. We have this fraction sitting here, and then we have a double negative. This is the same as 2/5x plus 2, right? If you have a double negative, that is one big plus. I would take the time to do that first before I cleared anything, because that's a little complicated, multiplying that by 5. Let's go there, multiply this by 5 here. Some people can, if you took, subtracted 2 and moved this to the other side first, that's fine too. So this would be 2x plus 10 equals -5. I think we had ones like that on the test we just took. Move the 10 over. Add two negatives together, get a bigger negative. Isolate the x. This doesn't reduce. All right, multiply, then add them together. This is what, 18? Negative times negative is a positive. This is really over 1. So -4, I just take care of the negatives when I do the top. So -4 times a -3 is a positive 12 over 3. 3 times 1 is 3, is y. 18 plus, I don't need to clear the fraction because 12 divided by 3 is 4. So I need to add that together and get 22 equals y. This one is got a fraction in it, and there's a multiplication going on and all kinds of things. I would go ahead and multiply this together, so you have decisions to make with all the things that you can do. So I find it easier to multiply first if there's something to multiply here. I know it's a fraction, but it's not like it's a distribution. I'm not distributing it. Well, I'm sort of distributing it, but I don't have distributed to two terms, just one. So I go ahead and multiply. So this is really 3/1, so 12/9 minus 5. There's a couple ways you can handle this next. You can reduce that fraction, because it is reducible, or you can change the 5 into something over a 9. The 5 into something over a 9. So 1 times 9 is 9. 5 times 9 is 45. 45 divided by 9 is 5. Okay, so we just sort of made that fraction bigger, so I can add these, or subtract these, however you want to say that. This is going to be y. The negative 45 is larger, so we're going to end up with negatives left over. If you subtract them, you're going to get that. So since I didn't reduce the 12/9 and use 9s, I need to reduce this some more. So if you divide this by 3, you're going to get negative 11/3. Okay. All right, and the last one, the warm-up. Here is my variable term. what I want to do is move this away. I have only 3 terms. These are not like terms, so I can't combine them. And I don't want to move this -5 over this way, because then I'll have nothing over here. And remember, I'm not supposed to move things so I end up with nothing on one side. So the only choice here is to add its opposite to make that go away. It's a coincidence. These are both now -5. So -5 plus another -5 is a -10 equals 4x. Isolate the x with whatever means you need. And then, so x is going to be -10 over 4, but they're reducible by 2. So this is going to be -5 over 2. Don't lose the negative. All right, this one here, this is just one term times another term. So I'm going to do that first. This is 2 over 1 times, I'm not going to touch the 6. 2 over 1 times a negative would be a -2 over 4. Did I do that right? -2 over 4, yep. I don't know that I need all the parentheses. That's the same thing as that. That's the same thing as that. And all this still equals y. So I know if I did this, this would just be like 5.5 or something like that, but you don't want to mix numbers and answer. So what is 6 in terms of something with a 2 underneath? What is 6 in terms of something with a 2? Well, this got multiplied by 2 to be a 2, so this is times 2, so that's a 12. 12 out of 2 over 2 would be a 6. So 12 minus 1 is 11 over 12 is y. That's how I would do that. Keep it a fraction. If you're going to be working with blocks, you want to keep it a fraction. Okay, that's it for the warm-up.